Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about the carbene. What is carbene? Types of carbenes, structure and bonding, formation of carbene, reaction of carbene. Now, what is carbene? A carbene is a molecule containing neutral carbon atom with a valence of 2 or 2 unshared valence electrons. You can see here on the carbon. Carbene are uncharged electron deficient molecular species that contain a divalent carbon atom surrounded by the sextet of electron and 2 substituents. The general formula is most carbene are very short-lived, although persistent carbene are known. Now types of carbene. Carbene are called singlet or triplet depending on the electronic spin they possess. Triplet carbene are paramagnetic. The total spin of singlet carbene is 0 while that of triplet carbene is 1. Bond angles are 130 to 150 for triplet methylene and 100 to 110 degree for singlet methylene. So triplet carbene are generally stable in the gaseous state while singlet carbene occurs more often in aqueous media. You can see here the triplet carbene situation and singlet carbene situation. In triplet, sp2 orbital and arrangement of single sin electrons, and in singlet both electrons are in the same row. Now structure and bond. Singlet, triplet and triplet. There are 2 types of triplet here you can see. The singlet carbene are spin paired. This molecule adopt an sp2 hybrid structure CH2, CHPH, CHPH2 like this. Triplet carbene have 2 unpaired electron. Most carbene have non-linear triplet ground state, nitrogen, oxygen or sulfur atom and halide directly bonded to the divalent carbon. So, singlet state, carbonations like natural या trigonal planar geometry, electrophilic character, singlet carbene generally participate in chelotropic reactions. So you can see the empty p orbital and sp2 hybridized. Triplet state diradical like in nature linear geometry and participate in stepwise radical addition. Triplet carbene have to go through an intermediate with 2 unpaired electrons where singlet carbene can react in a single concrete state. Now you can see here the unhybridized p orbital, p atomic orbital and sp hybridized carbon. So metal carbene complex have been classified into 2 broad classes, Fischer types and Schrock type carbene. So this first example is a Fischer carbene and the second one is a Schrock carbene. Now Fischer carbenes. A Fischer carbene complex are low valent complex stabilized by a strong accepting ligand, often CO. According to Fischer, carbene are relatively inert but tend to react as electrophile. In general, Fischer carbene are 18 electrons, coordinatively situated complexes, and therefore nucleophilic attack at the metal is not possible. You can see in this example. Now, Schrock carbene. A Schrock type carbene complex contains an early transition metal in a formal high oxidation state stabilized by strong donor ligands. So most of these complexes have an electrons count below 18 and are thus coordinatively unsaturated. Therefore, nucleophilic attack at the metal is possible because of electron deficiency. Now, formation of carbene. Alpha elimination means the elimination in which both the proton and the leaving group are located on the same atom. So, a strong base remove an acidic proton adjacent to an electron withdrawing group to give a carbonyl. Loss of a leaving group from the carbanion created a carbene. One of the best known elimination reaction occurs when chloroform is treated with base forming dichlorocarbene. You can see in this example. Now, more common dehydrogenations to form alkene are called beta elimination because the hydrogen and halogens are lost from adjacent carbon atom. You can see here the beta eliminations and alpha eliminations and then rearrangement example. Now, thermal decomposition of diazo compound. You can see if you have such type of compound, then formation of nitrogen and then formation of diazo compound, then heat more strongly, then the formation of carbene. Example are here. Now, photolysis of diazidine. After that, you have here carbene. Photolysis of ketene, you will get this carbene. So, reaction of carbene. Carbene are highly electrophilic species. Three major classes of carbene reaction: carbene insertion, carbene addition, and carbene rearrangements. So, first carbene insertions. You know, insertion are another common type of carbene reaction. The carbene basically interposes itself into an existing bond. The order of preference is commonly 1-axis bond where X is not carbon, CH bond and CC bond. Insertions may be or may not occur in the single steps. So, one step insertion. Now, carbene addition. The stereochemistry of carbene addition to alkene can be used as a test of whether the carbene is reacting via the singlet or triplet spin state. Addition of singlet and triplet carbene of alkene. Singlet and triplet carbene do not demonstrate the same reactivity. Triplet carbene should be considered to be dicritical, remember it, and participate in stepwise radical addition. So, triplet carbene have to go through an intermediate with two unpaired electrons, whereas singlet carbene can react in a single concerted state. So, alkene react with singlet carbene in a concerted fashion. Alkene stereochemistry is preserved in the cyclopropane products. So, you can see in this example. Now, carbene rearrangement. Wolff rearrangement. You know, the Wolff rearrangement is a reaction in organic chemistry in which an alpha diazo carbonyl compound is converted into ketene by loss of dinitrogen with accompanying 1,2 rearrangement. The Wolff rearrangement yields a ketene as an intermediate product which can undergo nucleophilic attack with weak acidic nucleophile such as water, alcohol and amines to generate carboxylic acid derivative. The Wolff rearrangement can be induced via thermolysis, photolysis and transitions metal catalysis. Magnetic aptitude H greater than aryl, greater than alkyl. Now, this is the example. You can see the formations of carbene and the formation of the products. So, this is the reference reaction mechanism in organic chemistry, S.M. Mukherjee and S.P. Singh, Macmillan publications. Advanced organic chemistry, reaction mechanism, structure, Jerry March and John Wiley. Jerry March is John Wiley.